Yeah, good morning, all the participants and respected resource persons of the today's session. A warm welcome to Bapatla Engineering College STTP program, sir. And I request all the participants, if you have any doubts, the section will be is in progress. Please be posted on chat box. After that, we will be look it on the comment segments, doubts and at all any requirements what you want. At the end of the session, we will let you convey the same to the resource persons. Okay. I think I request Dr. Suresh Mikili, sir. With your permission, sir, shall I read your profile, sir?
Yes, sir. Please go ahead.
Yeah. Thank you, sir. Thank you. I request Dr. Sampath Garu, please read the SARS profile.
Oh, thank you, sir. Thank you very much. Very good morning to all the participants. Welcome to day 8 session in ETEV. Thanks to all the participants for your continuous presence and cooperation with us. Up to now, we learned so many things in EV. Today, we are going to hear the voice of the eminent speaker, Dr. Suresh Mikili Garu, the IEEE senior member, IET member, working in IEEE department, NIT Goa. This is very glad to meet here in this online session. I'm very much happy to introduce Dr. Mikili Suresh Garu, giving the opportunity to me. I'm very happy. The main specialization areas of Suresh Mikili Garu is grid integrated renewable energy systems and power quality issues and smart electrical grid, power electronics applications to power systems and applications of soft computing techniques. And he is awarded the PhD from NIT Roorkela in 2010 to 2013 and MTech from the same NIT Roorkela. And his journals having 54 journals within the span of a few years. He published 54 SCI and Scopus journals in IEEE, IET, elsewhere, Willy, Springers, etc. And conferences, 27 conferences in IEEE and IECON, PES, and got awards in the conferences also. And two books in the CRC Press and Trial and Francis, and one project that is 40 lakhs DST SCRB ECR project allotted to Sir Mikili Suresh, Dr. Mikili Suresh Garu, and one JRF fellow is there, and one completed PhD student is also completed, and 3 is ongoing. Students are to be working under Suresh sir, and several projects are to be completed under MTech and BTech projects, and so many theses are also reviewed by our today's resource person, Dr. Mikili Suresh Garu. And one more thing is the talks delivered outside as 60 plus. His experience, I think so, in NIT, if I am not say wrong, nearly 7 years. If you divide with 60 with 7 years, each month he is having one session like this. So in his busy schedule also, he gave the permission to us and deliver his lecture in our STTP. And he is not only, he is the reviewer of IEEE PE, IEEE SG, IET PE, so many these IEEEs are reviewer by our today's resource person. And the membership of professional societies are 3 memberships are there: IEEE senior member and IET member and IST life member. So he is doing several academic and administrative duties in his NIT Goa. And one last thing is there is a coincidence between Suresh Mikili sir and our registered participants is this. So Suresh Mikili sir having citations, nearly 1200 citations are there, and our registered participants throughout the globe is 1200. So this is the coincidence between and the registration participants. Nearly daily 600 members are to be joined with us, and I very much thank to all the participants, and welcome to our beloved sir, Dr. Suresh Mikili Garu. Please start taking this session, sir. Thank you very much, sir. Thank you, sir.
Good morning, Ananda. Sir, am I audible?
Yes.
आवाज नहीं आई मुझे ना
आवाज बंद हो गई आवाज तो बंद हो गई
Sir, am I audible?
यहाँ से बंद करने का ऑप्शन नहीं आ रहा है इसको
Screen is also visible to us, sir.
Okay. Good morning, Ananda. First and foremost, I would like to thank Babatla Engineering College, head of the department EEE, madam and principal sir, and all the organizing committee, as well as the chairman. Each and everyone I would like to thank for inviting me to deliver a lecture in this 2 weeks short-term training program on emerging technologies in electric vehicles. Okay. And first and foremost, I would like to congratulate on all the organizing committee for their painstaking efforts to organize this 2 weeks online course in a grand way. So without any delay, so I would like to start my presentation. See, today we are going to discuss more or less what is the scope or what is the importance of an integration of electric vehicles with a smart grid. Then after that, we will see what are the limitations of a present grid, what are the essential features of a future grid, and what is the vital role of an electric vehicle in the performance of a smart grid. Then we will see a relational diagram, what are all the services we are having, and what are all the optimization techniques we are having, then what are the constraints like challenges and opportunities we are going to see. Then we are also going to see vehicle to grid technologies, and if time permits, I will try to explain Nation Smart Grid Mission. There is a 3-tier structure is there. Then after that, we will see what is the vision and mission of a smart grid, and what are the challenges and opportunities that we are having through a smart grid. Okay, so without any delay, so coming to the motivation for the Indian context, the accelerated electrification of clean transportation. So we need to accelerate the electrification of clean transportation, charging infrastructure, EV, electric vehicle charging infrastructure, and 21st century electric grid, that is a smart grid. These three are key contributors. One is clean transportation, charging infrastructure, and 21st century smart grid are the key contributors for the future proof of energy security, environment, and clean air. I'm having 3 objectives. The entire session will be on this only. I'm having 3 objectives. I want secured energy, the clean environment I need, and I want the clean air. To meet these 3 objectives, I need some contributors. What it is? The transportation should be very clean. I want charging infrastructure, and I want 21st century smart electric grid. Towards this, what Indian government has taken the steps? What are the initiatives were taken by our government of India? So under this, they have started National Electricity Mobility Mission Plan, NEMP 2020. Everyone might be knowing National Electricity Mobility Mission Plan. What it says, they have initiated this one in the year of 2011. 2011 they have initialized, and they have launched in 2013. In 2013 they have launched it. Okay, it aims to achieve national fuel security by promoting electric vehicles in the country. National Electricity Mobility Mission Plan, it aims to achieve national fuel security by promoting electric vehicles. The target was 6 to 7 million electric vehicles they want to promote. The reason why they have promoted, to get the clean air objective, they have supported the production of electric vehicles. and hybrid electric vehicles. So towards that, they have initialized one more mission, National Smart Grid Mission. National Smart Grid Mission. So under that, the primary driver of grid modernization should be through renewable energy sources and EV. The primary grid modernization should be through EV and PV. And they have targeted the renewable generation of 175 gigawatt by 2022. Under this, out of which 100 gigawatt from the solar, 60 gigawatt from wind, 10 from bio, and 5 from small hydro. Finally, they want to achieve a reduction in the greenhouse gas emissions and improved air quality. Okay, so that is the reason they have started an EMP plan and an SGM to promote renewable energy sources. The main objective is to reach clean air objective. Okay, what is the scope I'm having? What is the scope of a smart grid and an EV? If we consider electrical energy system, we are having transmission distribution. So generation, if you take transmission distribution infrastructure, which connects, one side will be I'm having large generation, one end, another side I'm having consumers. You understand? Generation, transmission and distribution is there, then there are consumers are there. In the middle, earlier it was only centralized generation was there, but nowadays people are going for distributed energy sources. As everyone knows, people are going for with the development of fax devices. Now, the DG sources play a vital role in our energy system. So, while doing the grid modernization, people have considered the distributed energy sources they have included in our energy system. So, there is a scope of smart grid is there, and second thing is reason why we are developing and producing various electric vehicles is to sustainably reduce the petrol consumption. Why we are going for? So what is a smart grid actually? What is a smart grid? Then why it is called as a, earlier it was an electrical grid. Why I am naming it as a smart grid? Reason is, in a smart grid, we are using information and communication technology. In the electric grid, we are using the information and communication technology to acquire the data. If you see what is a SCADA, supervisory controlling and data acquisition. So here what I'm using information technology and communication technology. With the help of information and communication technology, we are acquiring the data and we are acting on that information. Is the standards are proper or not? A voltage and current limits or frequency limits are proper or not? So what we are doing is, with the help of our information and communication technology, we will acquire the data and we are working on that behavior. Okay, on that information, whatever we are having, we're working on that. So that what is happened, it is two-way control. Earlier it was just one-way control. Now, by including IC technology or information and communication technology, the smart grid is becoming a two-way technology. And it is digital in nature. It is digital in nature. Okay, throughout the network, we are using the sensors. Now you see, earlier, if you see here, I'm having generation, a transmission, and there is a distribution is available. But now what I'm doing, I'm using my information and communication technology. I'm merging both. By merging both information and communication technology with my energy network, the real-time simulation will be there. Throughout the network, I can do the simulation. That means from each and every field terminal units, remote terminal units, I can acquire the data. What is the load? what is the active power, what is the reactive power, and how much amount of voltage is there, what is the current levels. So everything I can get the data. So I can do the real-time simulation. I can do the real-time simulation throughout the network, because more number of sensors I'm using in the smart grid. We are using sensors throughout the network. By using sensors throughout the network, I can do real-time simulation can be possible at each and every corner. Wide area reliability will improve. The reason is, why the reason? It is a digital in nature and two-way communication. The reliability is improved. And network optimization is possible. How is the network optimization possible? The reason, again, same. Because of two-way communication, more number of sensors are available. I will know that for each and every terminal or for each and every feeder, how much amount of load is connected. Okay, what is the existing power? How much amount of surplus power is there? Or how much amount of demand is there? So I can do the network optimization. By doing network optimization, I no need to go for investment of new power plants. Try to understand. Earlier, we were unable to utilize the entire power which is available. Now, through the sensors, through the smart grid, by considering more number of sensors throughout the network, or by considering smart meters in the network, okay, I can understand the network optimization in a better way. Optimization can be done. By doing so, we can reduce the investment on the power plants. We can increase the revenue as well. So real-time simulation is possible. Reliability is improved. I can optimize my network. I can increase even revenues. And because of this thing, because of maintaining this power quality, the customer participation will be increased. And as I said, we can also participate in the energy markets. Okay, so now that's what I told you. Earlier, conventional grid was electromechanical. It was just one-way communication. The telephonic operator used to get the data in one way, through telephonic way. It was centralized generation. So what happened? Only generation was the power is generated at one particular place, and it used to be transferred. And entire network, few sensors were there in the previous grid. And if any fault is occurred, the manual monitoring was there, manual restoration was there. That is the reason. Due to that, there is a time delay was there for clearings of fault. So there are chances of failures are more, and there were blockouts, and limited controller was there. That's the reason there was choice for few customers. But now in the smart grid, we are replacing electromechanical with a digital communication. And instead of one-way communication in smart grid, we are going for two-way communication. And instead of earlier centralized, now as I said in the first slide, we are going for distributed generation. I hope you understand. Then earlier there were only few sensors were there. Now in the smart grid, we are using throughout the network more sensors we are using. So that what can I do? Network optimization I'm doing. For each and every point field terminal unit, I will have the data. Self-monitoring is possible, fully automated, and self-healing is possible. That's the reason it is adaptive in nature. It can work under islanding condition. That's why it is pervasive control, and it is choice for many customers. Okay. Now, if you see, it's 2 minutes. I will complete this and I will move to EV. If you see past grid, how it was, there is a power flow indicated in the orange line, and information flow is indicated in the dotted lines. If you see here, coal, thermal, it is generated through a conventional energy sources. Okay, then power is transmitted and it is distributed. If you observe here, the information is one-way communication through a telephonic operator. It was the past grid. Now in the present grid, we are having SCADA system at transmission level, and we are having SCADA system at the distribution level also. Now, generation is not only non-conventional sources we are using. That means renewable sources we are using. It may include PV, wind, PV may be even our rooftop also we are considering. Now, to the past grid, We have included non-conventional sources, renewable sources at present, and power is a combination of conventional, non-conventional energy sources. And at residential level, we are having rooftop at present, and slowly even EV is coming into the picture. So here this was supervisory control. Now coming to the future, we are going to add even hydropower as well as throughout the network. If you observe clearly, throughout the network, charging infrastructure we are going to consider. You see, you observe here, this is a charging infrastructure at transmission level, even at distribution level. A government is planning in future every 4 kilometers it will be a one EV charging station. They are planning to consider. I will show you how many are there. Now you observe clearly. Now conventional, non-conventional is there. At distribution, rooftop is there. That means smart home. If office also nowadays people are considering solar system, that is a smart building they are considering. Okay, why we are calling it as a smart grid is, if I consider rooftop PV and EV at home, it is called smart home. At building, if I consider, it is a smart building or smart apartment. So EV PV integration, if I consider, if I use EV PV integration along with battery storage and smart meters, advanced metering infrastructure. So in the future grid, it is going to be most of the part will be taken by renewable energy sources. Most of the part will be taken by renewable energy sources. Most of the part will be taken by energy generation will be taken by renewable and EVs, electric vehicles. So that is the reason we are thinking about charging infrastructure. We need charging infrastructure. Okay, so that's the reason. Clean transportation, charging infrastructure, 21st century are the main contributors. So we are concentrating on charging infrastructure. Not only charging infrastructure, we are also seeing it storage. We are also seeing it the storage. Now, this is what the present, past, present, and future grid. Now, so today grid limitations are consumers are lack of information. Utilities are lack the mechanism to influence the consumer behavior. What it means? Because what are all the incentives are available through EV? What are all the PV incentives? So what is the importance of EV? What is the importance of PV? So consumers are lack of that information. They don't know the scope or what is the impact or of the EV PV. And what are the utilities we are having? It has lacked the mechanism to influence the consumer behavior. And we are having limited clean power, limited storage is there. So the essential elements what I need to consider is I need to improve the clean power. I need to increase the energy storage. I need to influence the consumer behavior. Any lack of information is there. So I need to bridge the gap. I need to provide the awareness. First one is we need to provide awareness. We need to, our technology has to influence the consumer behavior. Clean power has to be produced more or generated more, and energy storage has to be improved. Okay, so for that one, essential elements of a smart grid are deep energy efficiency, demand management, grid intelligence, clean power, electric vehicles, energy storage are key parameters. Okay, so under this, how we will do is we will consider the wireless communication, smart meters we need to consider, aggregate intelligence has to be considered. I will go a little bit further. So for that, clean power, for clean power we are considering, if you observe clearly, for a clean power we are considering it is a carbon free. At utility scale we are considering wind and PV, whereas throughout the scale we are considering PV. That means at household purpose, a building, residential, smart home or smart building also, PVs we are considering. Our EVs also we are introducing. Okay, So even EVs we are also introducing. If you observe clearly, earlier we are having, if you observe, earlier we were having generation was through either hydro, coal, natural gas and nuclear. Now slowly we have taken cost-effective steps. Then we are consider demand side management, which includes wireless communications, that means lossless transmission. Then smart meter infrastructure we are considering. Then we are considering information and communication technology. With the help of information and communication technology, we are doing SCADA integration, that is supervisory controlling and data acquisition. And we are doing monitoring and controlling. We are doing all distribution transformers are monitored and controlled. Okay, so phase measuring units we are using, automated substations, gas insulated substations we are doing. So that means we are doing grid modernization. That grid modernization, three parameters will be there. In the grid modernization, either I can do circuit topology wise or information and communication technology wise. It comes next. Okay, so grid intelligence I am providing, which includes monitoring and controlling of distribution transformers, full SCADA integration, then phase measuring units, automated substations. Then we are also considering clean power. Under the clean power, earlier it was, or nowadays we are considering the wind is at utility level, and whereas PV is throughout at utility as well as residential level also. Okay, and now we are also targeting electric vehicles. Towards this, we are also initialized electric vehicles. The reason is to reduce the oil consumption, but here only one problem is charging infrastructure is required. Okay, so now here if you observe, if you see the smart grid foundation, as I said in the first slide. So grid modernization scope is we need to do the grid modernization. For grid modernization, I'm having the option. The substation automation can be done. Circuit topology has to be upgraded. Telecommunication infrastructure has to be upgraded. Our IT infrastructure has to be upgraded. So that's why in the first slide, as I said, or first three slides, what I said, we are merging energy network with the communication network. So to make our dumb electricity into more smarter, so we are working on circuit topology, which is the feeders, substations, automation I am doing. So gas insulated substations they are going to provide. Then after that, we are also working on information and communication technology. What it is, throughout the network, wide area network or WAN, LAN, we are providing what ICT networks we are providing in such a way that two-way communication we are taking. So recent advancements in the information and communication technology we are adding. Through that, we are designing the smart meters. Through that, so under NSGM, there are R&D is there. I will explain that in the coming slides. So people are designing a smart meters with the proper standards. Okay. So distribution automation, substation automation, smart meters installation. Okay. So they are considering, these are the fundamental applications. Now, after that, by considering these changes at the ground level, what we need is some enabled applications are demand response will be proper and microgrid operations can be possible and efficiency will be improved. Finally, we are having a chance of plug-in electric vehicles. Our main motto is wide area situational awareness is our smart grid policy priority is. First one is wide area awareness has to be provided. Reason is there is a lack of information. We are unable to attract the consumers. Okay, so that's the reason. First one, wide area situation awareness is required. Demand response has to be taken care. Electric storage, electric transportation. These are main grid priorities. Under that, advanced metering we are providing. Cyber security we are providing because we want the secured power. We want the secured power. That's why we are taking advanced communication technology. network communications are play a vital role. Now, what is the benefit of driving electric vehicles? Now, you can save the money, a clear air you can observe, there is no tailpipe emissions. It can support independently and you can enjoy the ride. Now, mainly, I'm coming to the main topic. Now, if you see electric vehicle, there are different type of electric vehicles are there. It may be only pure battery based, pure electric vehicles are called battery electric vehicles, BEV. Pure electric vehicles. If you observe here, last one diagram, it is pure electric vehicle, battery based. It may be extended range of electric vehicle. So to that battery, gasoline I have considered. You see, and here there is a plug-in electric vehicles also there. Okay, so it may be series in nature or it can be connected in parallel also. If you observe here, it can be connected in series or parallel. When you consider either EV, exclusive EV or extended range of electric vehicle or plug-in electric vehicles, on an average, for one time of charge, you can travel up to 500 kilometers, 300 plus miles in the sense 300 into 1.6. It is up to 500 kilometers we can travel. Okay, so when I go for only battery, if there is an issue is there, so there is a problem, you can't go for a longer distance. So that's the reason people are considering hybrid electric vehicles. Okay, so one is with IC engine will be there, second one is battery based will be there. Okay, now if you see pure electric vehicles, there is no IC engine in the pure electric vehicle, only electric drive will be there. Its battery size is 20 to 80 kilowatt hour. Okay, some examples are Nissan, Tesla model. So those are. Whereas if I consider hybrid electric vehicle, which consists of both, hybrid electric vehicle consists of both battery as well as IC engine. Okay, it has IC engine, electric motor. Okay, so here in the hybrid electric vehicle, battery get charged by the engine itself. Okay, so its size is 6 to 12 kilowatt. Honda Civic or hybrid vehicle, if you see here car. But whereas the difference between hybrid vehicle and plug-in is, plug-in hybrid vehicle means it has also IC engine and electric vehicle will be there, but batteries can be charged from an external source, plug from the external source. So that's why mostly plug-in hybrid vehicles people are taking. So one example is BMW i8 and mild hybrid vehicle, So IC engine will be there and electric motor will be there. It is also hybrid only. But what happens in mild hybrid vehicles, we turn off the engine and switches to the motor. Okay, so it is automatically braking operation and restart operation will be quickly, it will take. Okay, if you see example is Chevrolet. Okay, there are different types of electric vehicles are there. It may be pure electric vehicles, it may be pure electric vehicles or hybrid electric vehicles, plug-in and mild hybrid vehicles. Now, if you see the conventional electric vehicles, conventional means then if you see conventional vehicles, only IC engine if you are having, only regular IC engine, no, with oil, with petrol which is running, or petrol or diesel. So conventional vehicles which is run by petrol and diesel, energy source is only petrol is there. The consumption is only petrol or diesel. So carbon emissions are very high. But if I take hybrid vehicle, in hybrid vehicle, as I showed you, both will be there. One is fuel will be there. Second one is in the hybrid also, if I take only hybrid range without plug-in, this is without plug-in, then the consumption is mostly petrol and little bit of charge will be done within that vehicle. So if I consider only hybrid electric vehicle, this type, second type, okay, the batteries get charged by the engine. Such type of case, the emission will be little bit more only. But whereas if I take plug-in vehicle, plug-in hybrid vehicles, so we are taking a source, energy source from both from petrol as well as the charging station. Both petrol and charging station you are taking. So what happened? Here range is increased. This is called extended range. Plug-in hybrid vehicles are what has happened. So fuel consumption is very less and electric charge is more. So emission will be further reduced. So if you take full of battery extended electric vehicles, full of EV, then you will have full battery will be there. There is no carbon emission. I hope you understand. If I consider pure normal vehicle or petrol or diesel based conventional vehicle, the source is only petrol, more amount of petrol will be consumed and emission will be, carbon emission is very high. If you consider hybrid vehicle, the battery driven by an engine, IC engine. So the energy source is only petrol, but here the consumption is the battery driven by a petrol. That's the reason the carbon emission is a little reduced, not more. But plug-in hybrid vehicles, I'm having external plug is there. So I have the energy source of both petrol and electric vehicle, EV. So that's why EV part will be more. The emission is further reduced. If I consider pure electric vehicle, only EV charging will be there. It is fully electric vehicle charge. More or less carbon emissions are further so much reduced. Okay. Now, suppose if I want to go for hybrid electric vehicles, I should have a charging infrastructure, or I should know how much time it can be charged. See, there are different levels of charging infrastructures are available. See, at home we can charge, fleet charging is there, public use is there. There are two types of charging is there, AC charging and DC charging. Whereas DC is fast charging. There is an AC charging and DC fast charging are available. So AC is mainly at home, fleet and public use, it is available. Whereas DC fast charging is only public and large fleet will be there. Okay. Now, if you take AC charging, there is a level 1 and level 2 are there. Under level 1, 120 volts, 1.4 kilowatt, 12 amperes, or 120 volts, 1.9 kilowatt, or 16 amperes is there. Okay. And whereas level 2, 240 volts, up to 19.2 kilowatt, 80 amperes is there. Now, suppose if I go for level 1 of AC charging, if I charge my vehicle at 1 hour, for 1 hour, how many kilometers I can travel is up to 8 kilometers I can travel, like 5 miles into 1.6, which is gives you up to 8 to 10 kilometers, 8 kilometers I can travel per hour of charging, low voltage. If I charge throughout the 10 hours, if I charge, let us consider maybe 80 to 100 kilometers I can go for a very low level of 120 volts. But whereas our household purpose 240 volts, 19.2 kilowatts, for 1 hour of charge, you can go up to 60 miles. Household, home charging, 240 volts. The difference between home fleet is, home is a single vehicle or 2 vehicles you can charge, whereas fleet is group of vehicles charging. At home, suppose you are having a business of vehicles, you have, otherwise is a nuclear family. So more number of vehicles are there. Or if you take if you consider your organization, let us consider our destination. In your organization, there are hundreds of vehicles are there, electric vehicles. So if fleet is nothing but, fleet is a group of vehicles will be charged at one particular place. More than 5 or like that, it is called a fleet. A large fleet is the high in number. Okay, fleet is like 5 vehicles, 10 vehicles, 20 vehicles. That is called a group of vehicles, is nothing but a fleet. So for a level 2, 240 volts, 19.2 kilowatt, for 1 hour of charge, 60 miles you can travel. What is meant by 60 miles into 1.6 up to 90 kilometers, 95 kilometers. 1 hour if you charge 90 kilometers, you can travel with 240 volts, 80 amperes, 19.2 kilowatt. So 500 kilometers if I want to charge. Full charge is 500 kilometers. Electric vehicle, full charge is 500 kilometers. For 500 kilometers, more or less 5 hours I need to charge. 5 to 6 hours I need to charge under AC level 2. Try to understand. For a level 1 charging, for 10 hours if I charge only 100 kilometers I can go. But whereas 240 volts, 19.2 kilowatt, for 1 hour of charge I can go 90 kilometers. For 5 hours of charge I can go 500 kilometers. Whereas if now government is giving incentives, they are looking for charging infrastructure. Okay. Now 200 volts DC fast charging, public use, 200 volts to 500 volts, 40 kilowatt if I take. For 1 hour of charge, your vehicle you can go up to 120 miles. That means 180 kilometers you can travel. So within 2.5 to 3 hours of charging, if it is at 40 kilowatt charging infrastructure, within 3 hours or within 2.5 hours, your vehicle will be fully charged and you can travel up to 500 kilometers. And if we have a charging infrastructure of 200 to 500 volts, 200 ampere and 100 kilowatt charging infrastructure, for 1 hour of charge, you can travel up to 300 miles. That means 480 kilometers. That means if you want to travel for 400 or 500 kilometers, 1 hour charging is enough. If you have a charging infrastructure of 100 kilowatt, 500 volts, 200 amperes, these ratings. So government is going to install that. Now there is no need, just this only cost and complexity tends to increase the faster the charging level. That means if you go for very budget level charging infrastructure, charging time will be more. If you go invest more and if you don't bother about charging infrastructure government is providing, then in an hour full charge can be ensured. Okay, but at household at least overnight your vehicle will be charged with 240 volts 19.2 kilowatt, 240 volts 19.2 kilowatt, just 6 hours of charge, 500 kilometers you can travel. That's the reason that your organization, if you are having rooftop PV with EV charging infrastructure, this morning you can go and till evening if it is charged, entire week is enough. Okay, now this is how the charging stations. Now people are earlier just they have considered, you observe here there is a electric vehicle charging station is there. They used to, here one box is there, they are charging in line by line. But now they are integrating EV with a PV. You see, now they are integrating electric vehicle with a PV. If you observe here, this is everything is this, for example I have shown you. Now you observe here there is a charging station is there. The roof is filled with rooftop PV. Here if you observe, for small 2 vehicle charge, 1 2 3 approximately 32 panels are there. Now if I consider a large fleet, if I observe here is a large fleet. If one charging infrastructure of 500 volts they have considered, 500 volts they have considered, there is a large fleet is there. At a time 50 vehicles or 100 vehicles can charge at a time. 50 vehicles, let us suppose, charge. On 50 vehicles, top rooftop PV if I consider. So how much power I can generate? I hope you understand. Here earlier, just they started with the Tata Motors. So electric charge was just directly charging station was there. But now they are considering EV PV integration in such a way that for a larger fleet if I consider, then what happened? Natural energy it will take. The entire sunny day, it will absorb the power. So which will be stored in the energy shockers like batteries. Then some amount of power will be taken from the solar. That means if I consider EV PV integration, some amount of burden can be reduced on the grid. I have to understand. Some amount of burden can be reduced on the grid. So that's the reason now people are going for the integration of why the integration is required. Integration of EV PV with the grid they are going. The reason is to stabilize the system or to see the demand response in a better way. Okay, so both are clean powers. Electric vehicle is a clean power and PV is a clean power. So first more we are doing the grid modernization in such a way that so some amount of demand response will be taken care by EV and PV. Okay. So no need of going for investment on the new power plants. Not only Tata, even Tesla also, you see, zero emission. These are the charging infrastructures. Okay. So as I said, we're having different charging locations are there. It may be residential, of home charging, destination charging, opportunity charging. Three types of charging locations are there. Home charging, destination charging, opportunity charging. What is meant by destination charging is, it may be residential. At home, 240 volts is the AC level of 1 or 2 will be there. Fleet in the sense, if you are having a business of vehicles, if you have more than 5 or 10 vehicles, you will go for fleet charging. One charging place, dedicated place you will provide in such a way that at a time 5 to 10 vehicles can be charged. So if you want to charge more vehicles, definitely you have to go for AC level of 2 and DC level of 1 or 2 if you have more vehicles. Destination charging is at your workplace, at your organization, even it may be BEC or some other thing. At your workplace, if your employees are more than 100 or someone 50 or 100 employees are there, so on an average more number of cars are there or more number of EVs or two-wheelers are there, then you can dedicate it some place charging or parking lot. That entire parking lot can be provided with a rooftop PV, and down you can consider the charging infrastructure, so that what happens, you can use the natural energy, extract the natural energy, and you can feed to, you can encourage the clean power. So at workplace also it is possible, destination charging. If we consider the workplace, definitely we need to go for DC level of 1 or AC level of 2, because longer time we are not staying there, so definitely it has to be. And destination charging is AC level 2, DC level 1. Destination in the sense regular transmission distribution level. Okay. And retail places, corridors, it is DC only. That means public usage will be, it will be definitely DC will be available. Okay. So now there are common myths are there. People will say plug-in electric vehicles can only support short trips, not daily commutes. Here you have seen. Okay. Just if I have a DC level of 1, in 1 hour of charging, I can travel up to 180 kilometers. If I have DC level of 2, 1 hour charging, 500 kilometers I can go. Okay. So it's not a short trip at all. Okay. So based on what type of charging infrastructure we are having, that matters. Okay. People say that plug-in electric vehicles can only support short trips, not daily commutes. No. So based on where you are connecting your vehicle, what type of charging infrastructure is available with you, so that matters a lot. Okay. On an average, it can travel up to minimum 100 kilometers to maybe 200 kilometers it can go. Second is plug-in electrical vehicles are not clean, burning gas will be there, dirty power plant, like that people will say. But if you consider IC engine has the emissions, carbon emissions are more compared to EV. And people say electric vehicles will make your energy bill go up, but government is giving incentives for EVs. Okay. And same, electric vehicles are far more expensive than an average car. Actual fact is, there is a FAME India scheme is there, a fast adaptation of manufacturing hybrid electric vehicles. Under that scheme, the government has given allotted for 3 years of span 10,000 crores they have allotted, and they're giving 40% of amount they are giving. Okay, so I'm going to explain. So it is not at all costly. So to promote the development of hybrid electric vehicles, see, there is a FAME India scheme they have developed. What is that is? With an objective of supporting hybrid electric vehicles in the market. Okay, objective is the promotion of or to support hybrid, plug-in hybrid, mild hybrid, and electric vehicles. Okay, so they have initiated or they have a FAME India scheme, faster adaptation, name itself faster adaptation and manufacturing hybrid electric vehicles. Okay, so when they have started is in 2013, actually 2011 started, 2013, Government of India has launched NEMP plan. Government of India has launched National Electric Mobility Mission Plan in 2013. They have launched. Okay, so their main target is promoting hybrid vehicles or hybrid and electric vehicles. Okay, first only I told you. So there is a target of to achieve 6 to 7 million sales by 2020. Is it clear? 2013, the plan has started with the aim of promoting hybrid and electric vehicles in the country, and the target is to achieve 6 to 7 millions. So with that initiation, they have launched this scheme in 2015. Okay, and the budget is under FAME 1 scheme to 10,000 crores. Out of 10,000 crores, they have utilized only 360 crores something they have utilized under FAME 1 scheme. Only 2.8 lakh vehicles were purchased under FAME 1 scheme. Okay, it was already completed by March 2019. Now 2019 April financial year onwards, FAME 2 has started. FAME 2 scheme has started with a budget of again 10,000 crores is allotted. Okay. Now we'll see the basic details about the FAME 1 scheme. So fast adaptation of manufacturing hybrid vehicles. FAME India scheme is launched in 2011 and unveiled in 2013. Okay. Aim is reliable, affordable, and efficient hybrid electric vehicles they want to encourage. Okay. So first initially they have approved 2 years, but actually what happened within 2017 nothing was happened. So then again they have extended up to 2019. Okay. Time to time they have extended up to 2019 it was there. Now under this framework, okay, so they have given more incentives amount they had given for mild hybrid, strong hybrid vehicles, plug-in vehicles, pure electric vehicles. Okay. Now there are 137, I believe, 130 30 manufacturers are there, 137 models are there. So manufacturers are developers. 30 companies are there. 30 companies are there, and they are developing 137 different models they have given under this category. Now, out of 10,000 crores, 359 crores only utilized and purchased 2.8 lakh only. Remaining 9,640 crores, it went to some other schemes. So that's what I told in the first slide. People are lack of information. So out of 10,000 crores, 9,640 crores were sent back to the government for some other schemes. You can understand how much percentage the people have utilized under the scheme. Okay. So here you can see total number of vehicles sold under FAME 1 scheme is 2,66,802. If you see Andhra, 9,676. Even highest is, I think, Maharashtra, maybe 34,631. Okay. And least is, I think, Himachal Pradesh, something is there. So Not Himachal Pradesh, Nagaland, Assam, something. Okay, so state-wise, how many vehicles are purchased? Now you see how much amount of fuel is saved. Per day, 52,000 is saved in all over India. 52,000 liters of fuel saved. After purchasing 266 vehicles, 266,000 vehicles, per day 52,000 liters was saved. That means oil consumption is reduced. Due to this, per day carbon reduction is 1,30,161 kgs is reduced. Till date, this much is reduced. So that is the reason we are achieving clean air or clean environment we are achieving by promoting electric vehicles. So under FAME 1 scheme, only 66,802 vehicles were purchased. Okay, and only 360 crores were utilized. So again, they have started FAME 2 scheme. So earlier they got understood 2 years is very nominal. Now they had given for 3 years. So FAME 2 scheme, again with an outlay of 10,000 crores for a period of 3 years. Okay, it is started. They started in the financial year of 2019, April 2019 they have started. Their main aim is supporting 7,000 buses, 5 lakh 3-wheelers, 55,000 4-wheelers, and 10 lakh 2-wheelers. 7,000 buses, 5 lakh 3-wheelers, 55,000 4-wheelers, and 10 lakh 2-wheelers. This is what they target. Okay. Now, if you see till date, total number of vehicles sold till date are 97,000 under FAME 2 scheme. This is under FAME 2 scheme. After 2019 April, before 2019, 266 were there. So fresh after 2019, April 2019 till date. That means almost how many years? 21. 2 years are over already. So 97,000 vehicles only purchased, including 2-wheeler, 3-wheeler, 4-wheeler, everything. Okay. Again, Andhra 3,732 vehicles are purchased. Telangana 3,300. Maharashtra 10,000 vehicles. I hope you understand the numbers. Okay. Now, by promoting this, total fuel saved is 61,760 liters per day. Okay. Now, under this FAME 2 scheme, 10,000 crores were allotted. 126 models are available because few models were dropped out. Okay. Earlier first scheme, 137 models were there. Now 126 models are available. Okay. Till date, approximately 295 crores were incentive amount is given. At 9,700 crores amount is still there. So that is the reason what they have done is, now recently 25th June 2021, the ministry has issued even a gazette notification saying that, sorry for 1 minute. Sorry. Now, see, Government of India has released one gazette notification on 25th June recently, 2021, saying that now again they have extended the period. See, the scheme is proposed to implement with effect from April 2019. Now, again they have extended the period of 2 more years till 2024. That means initially 3 years they had given, now 2 years they have extended. Now this FAME 2 scheme is up to March 2024. Okay. If anyone want to purchase up to 2024, this scheme will be there. The two up to March 2024. The recent order, this is now. Now, if you see, recently they have taken one more initiative. EV charging infrastructures they have considered. Okay, so first I will show this to give you a further push. Okay, so now Department of Heavy Industries under FAME India scheme, no, there are 7,000 proposals they have received. Out of 7,000 proposals, 2,636 charging stations they have sanctioned. 7,000 charging station proposal they have received, but they have seen, the screening committee has seen area wise, is it okay or not, geographic wise or location wise, and based on number of consumers wise. Okay, so based on that, they have sanctioned 2,636 charging stations they have approved in 62 cities. Okay, so across 24 states they have given, including UTs. Okay, now 317 out of 2,636, 317 EV charging stations highest is given to Maharashtra. Then 266 charging stations are given to Andhra Pradesh. 256 stations are given to charging stations are allotted to Tamil Nadu. 228 is allotted to Gujarat, 205 in Rajasthan, 207 in Uttar Pradesh, 172 in Karnataka, 159 in Madhya Pradesh, 141 in West Bengal, and so on. Okay, list is 10 each in Uttarakhand and Puducherry. So now the reason why that started is initially they have started promoting EVs, because even though they have given the promotion incentives, people were not attracted. Reason is due to lack of charging infrastructure. So now they slowly promoting charging infrastructures, and they are establishing charging infrastructures. Okay, first they have targeted. So these 2,636 charging stations, more or less, they have allotted to a million plus people, where the more number of population is there. Our government has decided smart cities. Some special category also they had given, but more or less where the population is more, and mostly given to the cities which are smarter. So coming to Andhra, Vijayawada they had given, it is comes under million plus people. So total, you see, rail, a new and renewable energy development of Andhra Pradesh. So NTPC is there. So in Vijayawada itself, almost, if you see, 80, 90, 92 they had given. And Visakhapatnam, they had given 71 stations. And Tirupati, under smart city, they had given almost, if you observe, 68. And if you see Kakinada, it is also smart city. So they had given 35 stations. So first they have encouraged, coming to Andhra, Vijayawada, Visakhapatnam, Tirupati, Kakinada, total together 266 they had given. So if you want remaining list, I can provide you. 1 second. I hope it is visible. Coming to the Assam, 20 stations, Bihar, 37 stations, Chandigarh, 70, Chhattisgarh, 70. Under Chhattisgarh, even Raipur also 25 they had given. Delhi itself 72 they had given. Even Gujarat 228. In that Ahmedabad, Vadodara, Gandhinagar, they had given specially. Even Karnataka, Bangalore, Gulbarga, Mangalore. Bangalore itself, see, 103 plus 37 plus 12. So in Kerala, 131. Maharashtra, if you take Mumbai, Nasik, Nagpur, Thane. So even Telangana, if you take Hyderabad, 4 million plus people. So 37, 49 plus 32. 100 plus or 120 approximately. Warangal, they had given 10. Karimnagar, they had given 10 stations. So this is the list, what they had given. Okay. Total, either million plus people, the cities which is having million plus people, or if any cities comes under the smart city, first they had given the chance to such type of cities. Okay. One second. One second.
Participants, please wait.
1 second.
Yes, sir.
Hope it is visible. Now, see what I mean to say is, so their government is giving incentives 10,000 crores they have allotted for only promoting hybrid electric vehicles. Apart from that, they are also encouraging us with a charging infrastructure. Okay. Now, so coming to the main thing. Now we are having why they are promoting. What is the reason is, if I go ahead with this EV electric vehicle, it is a clean power. As I said, if I consider EV PV integration, I have shown you. So mostly they are going for, government is planning to go for EV PV integration, electric vehicle and PV integration with a smart grid. So that what can be done is clean air and clean power and clean environment will be there. Okay. There is no, suppose if I go for thermal, the air is polluted. So here through EV and PV, the pollution is carbon emissions are very, very less. So that is the reason they are encouraging EV and PV together, rooftop PV and the EV. Our main motto is to achieve clean air objective and clean environment and secured power. Now, suppose if I have the electric vehicles in my hand, so what can be done is vehicle to grid charging is possible, or grid to vehicle also possible. So there is a bidirectional vehicle to grid and grid to vehicle is bidirectional. Vehicle to load is unidirectional. Vehicle to vehicle is bidirectional. Vehicle to home is bidirectional. So three are bidirectional. Vehicle to grid, grid to vehicle, bidirectional. Vehicle to vehicle is bidirectional. Vehicle to home, home to vehicle is bidirectional. And vehicle to load is unidirectional. Now, suppose if I want to connect grid to a vehicle or vehicle to a grid, here a converters play a vital role. See, if I want to charge back my grid, so I need compulsory, these are from research papers. See, a single vehicle can't be charged to grid. So there are group of vehicles aggregated together and it will give charge to a grid. Group of vehicles aggregated, the amount of energy will be aggregated and which will be connected to the DC-DC converter, then to the inverter, and the power will be fed. Whereas grid to vehicle, if I want to give 1 to 1 is okay, but vehicle to grid will be many to 1. Remember that. If I want to do vehicle to grid, it is many to 1, many vehicle to 1 grid. Whereas grid to vehicle is 1 to 1 connection. Okay. So why I need to connect vehicle to grid? The reason is, by connecting vehicle to the grid, number of vehicles, suppose there are huge number of vehicles are there. Night time, there is no work at all. Okay. Suppose they have purchased through Ola, some other thing. So they want to repay the amount. Suppose one Ola company is there, let us consider, Uber is there. They have purchased the vehicle through some loan. Incentives they have got. They want to repay the amount. What they will do? They will have one particular car parking will be there. Under that car parking, the charging infrastructure will be provided. Any surplus amount of power is there, it can be fed back. So that's why here converters, inverter structure, Second one is battery management system play a vital role while connecting V2G or V2H. Okay. So if I connect vehicle to the grid, what happened? Surplus amount of power is there, or if your vehicle is ideal, so you are not keeping it idle. So you are trying to give back some amount of power to your grid. So that what is happening? So you are reducing peak power demand, by connecting. So this EV and PV integration, as I said, better integration of renewable sources, PV, EV integration together. If we give the power to the grid, what happened? We can enhance the grid stability. Reliability will be improved, and it is a secured power. With EV PV, if I able to give power, we are enhancing the grid stability. Reliability is improved, security is improved. Okay, we can provide the grid services also. So by taking some amount of load, reducing the peak power demand, no need to go for investment in the new power plants. So there is a decrease in the investment in the new power plants, obviously. If there is a decrease in the new power plants, and if I have a surplus power, I can participate in the wholesale market. If I participate in the wholesale power market, I can generate the revenues. So that means vehicle to grid, if I connect along with a EV-PV integration, grid stability is there, reliability will be improved, security will be improved. At the same time, we are reducing the power demand, because of which no need to go for investment in the new power plants. We are generating revenues also. Now, if I consider vehicle to load, suppose let us consider you are constructing a building which is isolated somewhere, some farmhouse you are constructing. There is no light at all. It is an islanding condition. So you want to provide the power in the remote sites. Yes, vehicle to load, we can provide in the remote sites. And whenever the outage is there, it will act as a generator when there is an outage. And it is highly independent and self-consumption. And it acts as emergency power. Okay. If it is vehicle to load is, suppose load is a AC load, a small amount of a DC-DC converter and inverter is required in such a way that the combination is compulsory required to give exact how much is required to that particular element. And if it is a directly DC load, vehicle to that one you can consider, or DC is high amount of voltage required, then one DC-DC converter can be considered. So vehicle to load, if I consider based on type of load, either one converter or two converters required is decides. Then vehicle to home. See, I can connect vehicle to the home, home to vehicle is possible. Suppose if you want to change my vehicle, home to vehicle is connected. But if I have surplus amount of power is there, that's what smart home, smart building, smart apartment I said. Now, vehicle to home is also possible. Okay, instead of now, if you have a 5 or 6 vehicles you are having at home, all vehicles are fully charged, then you can give back the power to your home also. It is highly independent. It is act as a generator when outage. Okay, and it can work with integration with the renewable sources. What it mean? Rooftop PV I'm considering, and here VV is there. So definitely it is better integration with renewable storage and self-consumption. And if suppose if I'm not depending more on the grid, then we are reducing the peak power demand, the decrease in the investment, and even you can generate the revenues also. Okay, vehicle to vehicle means we can help other EVs. It is a self-consumption. Efficient EV parking and management is possible and highly independent. That means when you are going traveling, there is no facility of EV charging infrastructure. Suppose next 1 kilometer or 2 kilometers, there is no charging infrastructure. So how to charge my electric vehicle? Then one more vehicle, if it comes, you can help other EV also. Suppose now there is no charging infrastructure at present. So if the consumer is the person is good, then you can help other EVs also. That is possible. Vehicle to vehicle charging is possible. Highly independent and efficient EV parking management will be done. Okay. Now people are doing the research in this area. Now, at present, people are doing grid connect PV system, standalone PV system. They're working on different DC-DC converters and inverter topologies. MPPT techniques people are working. And people are also working on different configurations, reconfiguration, PVs. Along with that, if I do EV to grid, if I want to do electric vehicle, the DC power is there. Small amount of power will be there. If I want to connect, don't think it is a single EV, n number of vehicles will be there. Aggregation will be given to the DC-DC converter, bidirectional DC-DC converter, which will enhance the power, or it will be stepped up, or it will be boost. It will be boost, buck boost converter you may call. It will be boost the power. Then that power will be inverted. Then it will fed to a grid. Whereas reverse it comes AC to DC, stabilization, then DC to DC conversion, how much is required. So the best DC-DC converter has to be designed in such a way that for grid integration of vehicle to grid and grid to vehicle for a bidirectional. And one more thing, if I replace a grid with a home, let us consider, now ratings will be changes. The rating which we have considered for grid will be different. The rating of converter or inverter which is considered for home will be different, definitely. Now, you can consider smart home. This is a smart grid application. If I consider smart home application or smart building application, so I can consider what type of DC-DC converter is required. What is the advantage? Or what type of inverter is required? Okay, to connect it to my home. So for a smart home, EV-PV integration along with type of DC-DC converter, type of inverter topologies, you can work for your maybe research work. Okay. If I replace a grid with a load, let us consider. If it is an AC load, definitely both will be the DC-DC and inverter with a lower ratings. If it is a DC load, direct connection can be possible, or with one DC-DC converter also it is possible. Okay. Now, this is what I have told you. Vehicle to grid, if I want to connect n number of vehicles and we are aggregating it to. Now you see, there is a generation, central generation, high voltage network is there, a medium voltage network, low voltage network. If I consider three operations are there here. One is generation can be happen either through conventional renewable energy sources. That's what we have seen in the starting. Okay. Now the generation might be through wind, it may be through PV, or it may be through conventional thermal or whatever it may be. And now we can also generate the power grid enabled EV system. You see, EV with a battery. It is connected here. It is called smart grid operation. First one is EV with a battery. It play a vital role. Battery play a vital role. EV with a battery now connected to the converter. It is connected to the medium voltage. Okay. Now one more thing. If suppose it is a single. Now you have n number of are there. 1, 2, n number of EV charging station is there. So charging station also can be connected to the converter. These are called local DGs. Now at a low voltage level, EV aggregation you see. A residential area, one EV with a home, it is a smart home. If I take the building, a parking lot is there. On top of it, a rooftop PV is there. Down EVs are there. It is a smart building. It can be connected. So smart grid operation can be enabled. Smart home application can be enabled. Smart building application can be enabled. Okay. So what are the services I'm having? It may be unidirectional or bidirectional vehicle to grid. If I consider this, I can take a spinning reserve. That means a load leveling. It is mainly a grid regulation, peak shaving, reactive power compensation, renewable source energy support can be done. Through all these services, my main objective is load profile I want to optimize.
First thing is I want to a demand response I want to take care. Load profile optimization. While doing that, cost minimization. Why? Because I have considered throughout the network my it is smart grid is a digital in nature and it is a two-way communication. So by merging energy network with the communication technology, what is happened is the network optimization was possible. Reliability is improved. By network optimization, load profile optimization is possible. Am I clear? So because throughout the network, I'm using the smart meters. Throughout the network, I'm using the ICT, information and communication technology. Throughout the network, wide area reliability is there. So real-time simulation I'm doing. By doing so, I know for each and every terminal or for each and every field, what is the load or what is the demand and what is the generation. So first thing I can do is my objective is load profile optimization is possible because of which. So by doing so, no need to go for investment on the new power plants. So cost is minimized here. Because here I'm encouraging EV and PV smart operations. So carbon emission is obviously reduced. Carbon emission is obviously it is reduced. By cost is minimizing, revenue is maximized. If carbon is minimized, loss is minimized, the efficiency will be optimized. Reliability will be improved. So by considering smart grid operation with EV and PV, load profile optimization I'm doing, at the same time, cost is minimized, revenue maximized. Carbon is minimized, losses are minimized, efficiency is improved, reliability will be improved. But there are some constraints are there. What are the constraints? Availability of EV, driver behavior, what is the charging rate, what is the discharging rate of your battery, state of charge limitations, okay, and owner and aggregator decisions, and electricity rate, what is it feasible or not, system power balance is happening or not, power equipment limitation, charger capacity. There are several constraints are there. If we able to bring it into one platform, so all these things are possible. So that's what, as I said, so generation is through renewable and non-renewable sources. In the grid, with the help of EV charging infrastructure, vehicle to grid application is enabled. It is called a distributed generation. At lower level, smart home application, smart building application is enabled. So as I said here, batteries play a vital role. So you may consider different type of batteries are available: mechanical, electrochemical, electrical, thermal, chemical, thermochemical. Different type of batteries are available. So we need to choose which battery suits more for EV, which battery suits for what type of battery has to be considered for plug-in vehicles, what type of battery has to be considered for hybrid vehicles, what type of battery has to be considered for mild hybrid, what type of battery is suited for strong hybrid. So it's not like single battery will be used in all vehicles. No, no, no. So based on what type of application, what type of vehicle, so you need to select the battery based on charging and discharging rates, based on state of charge. So if you see here, supercapacitor, DC-DC converter, battery, both combined together, motor drive it is going. I will show you here. If it is an electric vehicle, pure electric vehicle, battery, DC-DC converter, inverter motor drive, and it is given to the engine. Whereas hybrid vehicle is there. If I am having plug-in hybrid vehicles, initially it will start with, there is an IC engine is there, combination of IC engine and battery is there. IC engine, generator, converter through motor, one operation, series parallel operation. After it reaches certain range, automatically it will be switched to battery. So battery, this way it will go. Battery, converter, inverter, motor. Initially it will start with, engine will start with a fuel with a generator, DC-DC converter and a motor. So it is a only battery based. This is hybrid vehicle. Okay. Now, if I want to go for V2G or G2B, so I need to see state of charge, what is the percentage. If it is less than 70, then I should not connect vehicle to grid. Grid to vehicle, I have to take. If suppose departure time, arrival time, I will see. More time your departure time is there, like your expected time going is very high, then I can connect it to vehicle to the grid can be connected. So I need to see what is the charging discharging rate, what is the state of charge, and when is your arrival, when is your departure. Based on all these calculations, so it will be connected. This is what I have shown. One is gas line is connected, tank, IC engine and generator. Second one is grid connection. Now this is battery based. Electrification, where is the charging infrastructure is available and where is the connectivity. Okay, and diverse mobility, then autonomous driving. We need to see vehicle to vehicle connection is possible. Charging can be done through the stations. Okay, are we connected with other people or not, or the wide area network connections. Okay. So there are 4 technologies people has to look, they're working on it, but there are some drawbacks are there. What it is, people are lack of information. So first one is, okay, rules and business process must be clear. First thing, limited coordination between the stakeholders is there. We need to ensure that battery degradation, charging and discharging, and state of charge. So proper standards we need to maintain. And there are 30 companies have come. 137 models were there initially. Now also 30 or 60 companies are there, and 126 models have come. But the problem is non-uniform communication protocol. Standardization is not there. Okay, so that is the reason. And here I want to tell you, for 1 kilowatt hour, they are giving you 15,000 for 1 kilowatt hour for your vehicle. Suppose 20 kilowatt, you are based on your battery range. For 1 kilowatt hour of battery range, they are giving up to 15,000 rupees. If it is a 20 kilowatt hour battery, then you see 15,000 into 2, almost 3 lakhs they are giving. So based on your battery range, the incentives are decided. Okay, so because lack of standards, non-uniform protocols are there, battery degradation is there. So during technology side also we need to focus, and we don't know EV full charge availability guarantee, so we need to take care of that. So we need to provide the awareness of VTX capabilities, then subsidies. Okay. Now, so this is what we have seen. So why we are going is, why integration of PV required is. So we'll see if time permits. Some 10-15 minutes I will see what smart grid vision and mission also we will see a little bit. Okay. Now, what is a smart grid vision for India? To transform Indian power sector into a secure, adaptive, sustainable, and digital enabled ecosystem. Transforming Indian power sector into secure power. It should be adaptive in nature. It should be sustainable in nature and digitally enabled ecosystem. Why it is required? For a reliable and quality energy. Okay, we want reliable and quality energy. Quality means the clean air, clean environment, and secure power. Okay, for all with the active participation of stakeholders. That means by doing so, reliable and quality energy, we can attract more customers to participate. So towards the secure Indian power sector, we want to transform the power sector into secure. For that one, what initiatives we have done? Information and communication technology we have considered. That communication network we have considered. So cybersecurity is improved. Now coming to adaptive in nature. Now the grid modernization they are doing, smart meters they are considering, gas insulated substations they are considering, and phase measuring units they are considering, and SCADA system they are considering, monitoring and controlling they are doing. So that what is happened, your network is adaptive in nature, and whatever the advancements they are considering now, is sustainable for longer periods. One is, it is a secure, adaptive in nature, sustainable for longer period, and it is digitally enabled. So by considering all these, we can provide reliable and quality energy. Okay, for this, Government of India, starting only I told you, so they have launched NSGM, National Smart Grid Mission. There is a three-tier structure is there. Under this three-tier structure, the main governing council is Ministry of Power. The chairman is Ministry of Power is governing council. Under this, type 2 consists of two committees will be there. One is a technical committee, second one is a power committee. Now, technical committee will be chaired by Central Electricity Authority, the managing director of Power Grid. Technical committee will be headed by the Power Grid director. Whereas the empowered committee will be taken care by the Secretary of Ministry of Power. The finance related things will be taken care by Secretary of Power. Try to understand. So it's a three-tier structure in SGM. It consists of governing council, mainly it is under Ministry of Power. Now, coming to type 2, technical two committees, one is finance committee, second technical committee. Technical committee will be headed by Power Grid director, and he will give inputs to the finance committee. So they will decide, Secretary of Ministry of Power will decide how much amount of power has finance has to be allotted. Now, under this, Tier 3 will have NSGM, National Smart Grid Mission Project Management Unit is there. There are 4 units are there. One is Policy, Planning, Monitoring Unit, Data Management, Cybersecurity Unit, R&D and Standards Unit, Research and Development Technology and Standards Unit. Last is Projects Training Capacity Building Unit. There are 4 units are there. Now, the first one, coming to the first one. So this entire thing is towards National Smart Grid Mission. Now, policy planning and monitoring, as the name suggests, this unit will look after all the policies which has to be implemented or to be implemented. Okay. When to plan, where to plan. Policy is, suppose there is, I have shown you the first diagram, triangular diagram. What are the enabled applications? Now, circuit topology, I need to take care. Feeders, substation automation, information and communication technology, so and smart meters, demand side management. So, what are the policies has to be implemented? So everything will be taken care by the first unit. And planning, when to plan, where to plan, what is the location and when to plan. So after planning, after implementing the policies, there is a one more section, monitoring and controlling section. So how it is executed and how it is working. Try to understand. Not only policies is planned, and not only when to execute, where to execute, and people will monitor. There is a Quality Council of India is there, QCI. So they will ensure that whatever the power quality standards, whatever the standards of the meters, so how best the network is working. So there is a monitoring and control unit is there. So first unit will look after what policies has to be implemented, when to plan, where to plan, and monitoring of the implementation of the plans, monitoring and controlling of the electrical power system. And coming to the second one. Second unit will look after data management and cybersecurity. Now, once they plan, so information and communication technology, we are merging. Now, so what about the cybersecurity features? Any power theft is happened? What about AT&C losses? Annual technical and the commercial losses, how much is there? So how much amount is generated? How much amount is demand is there? And how much amount of theft is happened? So entire cybersecurity and data management, like entire SCADA system will be taken care by this second unit. Now, Third unit is the main unit in consultation with Smart Grid Knowledge Center. In Manesar, there is a Smart Grid Knowledge Center is there. In consultation with those people, there is a research and development technology standards unit is there. Now, that's what, no, for a secure, adaptive, and sustainable digital enabled system. This R&D unit, technology unit, there is a standards unit is there. Bureau of Indian Standards, BIU. Okay, so whatever the meter is developed, okay, whatever the smart meter or phase measurement unit, automatic metering infrastructure. So all the meters has to meet particular standards. So will these meters, will this advanced metering infrastructure met the standards or not? It will be checked by this particular unit. And one more thing, they will also work on R&D. So here through R&D, there are two things are there. Now, NICM is working with globally and nationally. Under this, they have promoted mission innovation. Under mission innovation, suppose you take through conferences, through journals, through books, other things, R&D, they are working. So they will see recent advancements in that area. First thing is through the conferences, through the journals, through the books, through the research, what is happening, R&D will take care. And what they do in the R&D unit, initially, small scale, they will develop. So initially, they will take the new technology. So initially, they have started pilot projects and they have seen in a small scale, they will implement, they will see standards are properly small scale, then they will go for wider range. They will go for wider range. So R&D technology ensure that recent advancements they will take and they will implement in a small scale, lower rating, and they will check the standards. Then they will go for, give it the input through the planning and section. Okay, yes, the standards are proper. Now for this, there is a projects training capacity building unit is there. Under innovation mission, through DST projects, they are inviting some projects. R&D, no, there are, one is globally they are checking conference journals and other research, and they are going for pilot projects. Not only that, they are also giving through DST projects also, they are encouraging people to apply. Now, projects training capacity building unit. Now here, if any R&D new technology is there, small amount of projects are given through DST or to particular company, to particular discount, they are giving. They're training the people, they're checking, they're building, they're checking that, and they are seeing the standards. Okay, R&D in consultation with projects and training capacity unit, what they're doing is they're designing, they're developing some models, and they're checking the standards, and if they satisfy, then they're going for implementation. Okay, I hope it is clear. Okay, so we are having policy planning unit and monitoring unit. Mostly that is related to all the policies, all the planning, all the monitoring units, data management and cyber security, R&D and projects unit. Here, even we will provide the awareness to the people also, because new technology has come. Our local distributed company people, they might be not knowing what is a new technology. There are lack of communication and lack of mechanisms. They don't understand what the technology is. So that's why they are organizing more events like this. And even this is for the faculty. Now they are organizing more events for even the electricity people also, so that awareness will be provided. Okay, now, and this is 3-level structure, or 3-tier structure: governing council, technical and empowered committee, national smart grid mission, and there are consultants and advisory bodies are there. Now coming to the state level project management unit, it is chaired by Secretary of Power. Under this, there are distributed utilities are there. There is a smart grid cell is there. Consumers will be there. Local bodies will be there. In collaboration with these bodies and in collaboration with state level bodies, with the consultant advisory bodies, and in consultation with empowered committee, we are working on smart grid modernization or grid modernization. We are working. Try to understand. This is central level. People are working. Now coming to the state level. State level management unit will be there. Distributed companies will be there. In it, under smart grid mission, what is the scope is deployment of smart meters and advanced metering infrastructures, substation renovation and modernization. Okay, then development of distributed generation in the form of rooftop PVs and EVs. Okay, then people need to do real-time monitoring and controlling of distribution transformers. One thing is deployment of advanced metering infrastructures, smart meters, substation modernization, development of or integration of EVs and PVs, monitoring and control of distribution transformers, provision of harmonic filters, fax devices, provision of the fax devices, inclusion of fax devices to improve the power quality measure. Okay. And not but not the least, creation of EV charging infrastructure. That's what first slide, charging infrastructure. Creation of charging infrastructure for supporting EVs and development of medium-sized microgrids. Okay. Now, what happened? Journey till date is the smart grid mission, no, NSGM. So it is under the Ministry of Power. Early steps 2010 it has started. They have initially started Indian Smart Grid Task Forum. Okay. So under the Ministry of Power, they have started one forum. Okay. Smart Grid Forum or force they have started, and then forum has been started. Force is nothing but the people, the group of ministry people under Ministry of Power. They will give the directives. Then forum has started. In these stakeholders, everyone will participate. They will give their inputs. Then they have initialized some pilot projects. Total pilot projects are 11 smart grid projects are there. One smart city pilot project is there sanctioned, out of which 50% funding will be again given by NSGM only, Government of India only. Okay, so these are all worked under Central Electricity Authority of India. Indian standards, no, Bureau of Indian Standards they have to follow. Okay, now these 11 smart grid and one smart city projects, no, under implementation is there. It is released in the year 2010 they started, but released in 2013. Standards were published in 2015. Grid regulations they have started. Then once through R&D they have designed one test bench. Then smart grid knowledge center they have developed in Manesa. Then they have seen the functionalities, then finalized. So what they have done, initially they have started 2013, slowly meter standards they have developed, then some regulations they have put, again they have tested it through CPRI and Power Grid. Then after that they have seen the functionalities, then they finalized, they revised it. So through continuous process, now they are in the final stage of finalizing the standards of advanced metering infrastructure. So under smart grid mission, there are 5 main projects are there. Chandigarh subdivision 5, Chandigarh excluding division 5, Thiruvananthapuram, Jharkhand and Orissa. Okay, so it is comes under IPDS, the Integrated Power Development Scheme. Integrated Power Development Scheme. Earlier it was called as Restructured Accelerated Power Development and Reforms Program. Okay, so under that, so smart grid pilot projects were pilot in the sense named as small in scale. Ajmer, Assam, Mysore, Himachal Pradesh, Puducherry, Tripura, even Hyderabad, Telangana, that is GD Metro, Haryana, Gujarat, West Bengal. One smart city is there, that is IIT Kanpur. Knowledge center is Manesa. So quickly I will complete in 5 minutes. Now, what is the summary? So what they have initialized, why the smart grid, the pilot project they have initialized it is advanced metering infrastructure they have implemented everywhere, all 11 places, including IIT Kanpur. This is a smart city. Remaining all are smart grid projects. one knowledge center, one smart city, 9 distributed companies. Try to understand. 9 distributed companies are there. One smart city, IIT Kanpur. A few hostels and a few faculty houses they have considered. Then knowledge center Manesar is there. What they have implemented is under this advanced metering infrastructure, building using advanced metering infrastructure, like no need to go personally, automatic building app. Then peak load and management they have considered. Power quality management. Peak load management is the outage management, like demand response to take care. Okay, so peak load management, power quality management they have seen, the outage management, microgrid operation. So everything is implemented by Manesar Knowledge Center. But other places, advanced metering infrastructure is implemented. Others they have started implementing. It is yet to implement. Okay, so they are under process. Now, why the smart meters they are considered? Advanced metering infrastructure, power quality management, peak load management, outage management, microgrid. All these things why they are considering is to do the grid modernization. And by doing so, I can make sure that secured power we can get, which is an adaptive in nature. It is digitally enabled and it will be a sustainable power. So the person can rely, okay, and we can ensure that a quality power. So that's the reason they have started implementing this. Okay. Now, so NSGM to plan first, what is the mission is they have to plan and implement the policies, and they have to see what is the area, what is the existing thing, what are the drawbacks. So how to replace it, how to do the restructuring. Okay, how to replace it. They have planned it. Few places they have started. Under NSGM 12th plan, 980 crores were given budget. Okay, the support of 338 crores were given by NSGM. Okay, to implement that projects. Okay, but key challenges were at the initial stage, pilot stage, lack of skill and readiness in the utilities. Because when they want to implement the pilot projects in 9 distributed companies, the people when they go and implement smart meters, advanced metering infrastructure, peak load management, people were not skilled. They were not readiness in the lack of readiness in the utilities. Initial response from the industry to prepare smart meters, it was not that. And smart meter standards were delayed because 2013 they have started, 15 they got the standards. They've checked it by CPRA. They finalized it recently. So smart meter standards were delayed. And one more thing problem is the utilities come out with different set of specifications of smart meters. One is coming with one specification. There is no uniformity at all. And one more thing, integration with existing IT system, information and communication technology we need to add. So lack of support from these people. And one more thing, if I want to sanction any of some of the project, generally people will go for budgeting or total tendering process. For tendering process, generally who is the lower one, L1 cost, for the person it will be given. But whereas their approximate cost is and L1 cost is huge. But whereas L1 are more they have come. So that is the problem. So lack of skill, lack of readiness in the utilities, response is not that much good from the industries. Smart meter standards were delayed. Slowly they are standardizing. And integration of IT technology, there was a lack of support from the people. Now, at current stage, testing facilities are there in the CPRA for smart meters. Interoperability issues, little bit is there, like this IT is there. No? So now they have little bit set it, and they have adopted smart grid regulation, business cases of smart grid they have seen, and skill development of utility staff. Like under skill development, they have organized some events like technical events and awareness they have created. and consumer engagement has done. So some opportunities are, we can engage the industry. 35 million smart meters they have planned, and full scale projects 4 only there. One Kerala they have discontinued. 596 crores were given, and the government of India has given 180 crores. Okay, 40,000 megawatt of rooftop by 2022 they have planned. Okay, implementation of charging infrastructure, efficient use of demand side management, demand response, peak load management, power quality management, everything has to be taken care. Okay, so it finally now EV/PV at the initial stages they have started. There is a huge opportunities are there. There are challenges are there. Huge opportunities also there. Okay, so with this, once again, I will conclude in 2 minutes. So what we have seen, initially accelerated clean power transportation, charging infrastructure, and 21st century grid. These 3 are main important for clean air, clean environment, security. Under that, 5 minutes, just I will conclude. Under that, National Electricity Mobility Plan they have given. Under that, they have supported EV. Okay, production of EV. Then they have initialized NSGM, National Smart Grid Mission. Then they have supported renewable energy sources. They target. Main aim is to reduce carbon emissions. That's why they have merged EVs and PVs. They have merged EV/PV technology. Sorry, they have merged energy network with the communication network technology. Okay, so by merging, so real-time simulation is improved, and network optimization is possible. Wide area reliability is improved, and more number of participants can be done. So that is the reason. So we are moving for that. So then we have seen what are the enabled applications. Okay, so smart metering infrastructure or IT infrastructure, communication technology, circuit topology. So through that, what is enabled is demand side management is enabled. Demand response we have taken care. Wide area awareness is improved. Then after that, smart meters, smart homes, smart buildings, smart grid application is enabled. So peak load management we are taking care. Power quality management we are taking care. Advanced metering infrastructure. So these are the opportunities. Coming to the EV, different types of vehicles we have seen. Different types of charging infrastructure we have seen. After that, we have seen then at what level how much charging will be. Then FAME India scheme, fast adaptation of manufacturing hybrid vehicles. So first scheme we have seen 2,80,000 vehicles were purchased, 360 crores were utilized, but the incentive is 10,000 crores. Then after that, FAME 2 scheme, till date 97,000 vehicles were purchased by the people. Same 10,000 crores were allotted. So within 3 years, nothing was progress was there. So that's why it is extended further till 2024, March 2024. Now, then after that, we have seen type of vehicles, how the emissions will be. Then we have moved to how the relational diagrams, what are the services, what are the optimizations we can achieve, what are the constraints we have seen. Then we have seen V2X technologies, vehicle to grid, vehicle to home, vehicle to vehicle, vehicle to load. We have seen what is the advantage, what it is the disadvantages. Then we have seen the power diagrams, like what is the circuit topology is required to integrate V2X technologies. Then slowly we move to why we are going for this. What is the importance of a smart grid? So smart grid vision we have seen, smart grid mission we have seen. Then under smart grid vision, how the NSGM has developed. What are the units we are having? 3-tier structure we have seen. How many units we are having? What is the roles and responsibilities we have seen? Then after that, we have also seen what is the scope of national smart grid? How many projects are there? Till date, what is the journey of NSGM and what are the challenges, opportunities are available? Okay. Thank you. Thanks for your time.
Thank you, sir. Thank you very much, sir. Participants, if you are having any queries, please ask. This is the right time to ask the queries to resource person. Any questions from the participants? Sir, one of the participant asking the question in YouTube, sir, live. So, shall I read that one, sir? Suresh, sir.
Okay, sir. You can.
Yes, sir. Yes. Thank you, sir. Thank you very much. To start a charging station in Tamil Nadu, procedure we have to follow for a common man. Is there any possibility?
Sir, so for that one, actually what they need to do, there is through, as I told you, mission innovation is there. Under mission innovation, there is a DST enabled projects they have invited, sir. DST enabled projects. What it means is, see, first they need to send a project proposal to the people. It has to be screened. Suppose not only this charging infrastructure I'm talking, it may be any new topology or new battery management system, anything they want to implement towards sustainability of the energy. It may be PV or EV, just generalized I'm telling you. So what happens, they need to send a project, it will be screened by the committee, you need to implement, you need to see under a pilot project, you have to show that, then they will give you that advancement. Coming to this charging station, he need to show what is the facility is having. Okay, so their grid is in how much distance it is available, and what is the space, what is the availability. If they run there, how much amount of outlay budget has to be given. If suppose if they want to consider that, what is the minimum amount other any industry will they support or what. Understood, na sir? It's not like a just layman. Like through one particular distributed company, through the power grid, they need to coordinate. It's not like one individual. It's through distributed companies they need to initiate the process, sir.
Okay, sir. Thank you very much, sir. Another question, sir. This is the common question. That is, when we are talking about vehicle to grid, Indian EV driver mentality is like, why I discharge my battery by V2G? So in that situation, how we can introduce V2G technology?
That's what, sir. See, this is mainly meant for mass charging, sir. That means fleet charging. This is meant for. It is not meant for individual charging. It is meant for mass charging, like fleet charging. More number of vehicles are there, surplus amount of energy is there, then only you can do. Power quality issues will come. This is one opportunity we can do. It's not like not at all implemented. This is the one possibility people can do, but we need to see the solutions. So how to overcome that problems? This is the budding question only. Now they have not yet implemented. Just these are the ideas can be done.
Sir, and Vinci Joseph asking, what are the challenges while integrating EV to grid? How to monitor?
That's what, sir. We need to see, make sure that, so what is your state of charge? What is the battery charging, discharging? How much time it is available? So are we really able to give quality power? Or sometimes there is a problem of power quality issues also may come. Reactive power we may inject also. So we need to ensure that the quality management and quality controlling has to be done while injecting the power also. So all demand side management issues has to be taken care. Now people are working on it. That is a research is going on, sir. So we should make sure that while integrating that, load leveling has to be seen. It should not be like reactive power compensation has to be done. We should not inject the reactive power, or we should not imbalance the system. Okay, so make sure that we are providing it. It's not like we have to sure that state of charge also properly has to be considered, sir.
Thank you, sir. Another question from YouTube, Dr. P.B. Karandikar. According to you, what are the research areas in electric vehicle to some other E2X?
That's what, sir. See, as far as I'm concerned, people are working on mainly battery management system. People are working. First is that one, battery management system. And second one is, see, if we consider hybrid electric vehicles, whatever battery is required. If I consider plug-in electric vehicles, if I consider EV, so mainly first focus is hybrid electric vehicle. This one, battery management system, play a vital role. Second one is when you're coming to the integration of any of the converter, or generally, at least if not the smart grid, at least I can connect my vehicle with the home at least. So for a smart home application, what type of DC-DC converter can be best fitted? What type of inverter topology is required? So at least that one we can work. So main now people are working on battery management system, smart home and smart building application. Now people can work. That means type of DC-DC converters for electric vehicles.
Next one, sir. Next question, Prashant Revankar. What are the major challenges in Indian grid to integrate renewable energies? That is the question asked in the YouTube channel. What are the major challenges in Indian grid to integrate renewable energies?
That is the general. See, if you integrate the, there are grid challenges are there. There are several reactive compensation we have to see. See, power quality issues are there, and harmonic issues are there, and load level imbalances are there. So we need to make sure that everything should be in the particular standard. So the power quality management and peak load management I have to see. Okay, when you are integrating it, it is not like just small amount of energy I can't integrate. No, so PV I need to see. When you solar PV system along with our wind or hybrid system, if I want to integrate it, make sure that there is a stability power you are integrating. It's not like only morning time I can send the power, night I can't do. So what you are having battery backup. So while doing that, I have to make sure that stabilized power I am giving or not. I also make sure that so reactive power how much I'm injecting, or real power how much I'm injecting. So peak load management or power quality issues has to be seen, sir.
Thank you, sir. Any other questions from the participants who are in Zoom link? Any questions?
Someone asked this one. So what is how much amount of SOC is required? So SOC, minimum 70% has to be maintained. State of charge, at least minimum 70% has to be maintained. So if you want, there is a scholar.google.com personal email also I give you. There, if you type now earlier there was a research on grid connected PV system, standalone PV system, more research is there, even power quality issues. But now people have started working on integration of electric vehicles, battery management system in electric vehicles. There are little bit hundreds of papers are there. So there the data people are now producing. So there about the state of charge, or maybe about this optimal control strategies. No, it is available there. Okay, the full details is available there. Okay, so this is scholar.google.com is there. You might be knowing. So from there, you can download extended range of papers like exclusively on EV, PV integration and electric vehicles, the two battery management system. What is the state of charge, charging capacities of electric vehicles? There are journal papers are available. Several papers in depth.
Thank you, sir. One question, sir. AC charging level 2 there, when you are discussed there, at 19.2 kilowatts, it will give 60 miles approximately mileage. When you consider the DC charging station, then 100 kilowatts will get 300 miles. If you calculate it for 20 kilowatts, 300 miles approximately, both are same, sir. Then why you are go for DC charging? Why you are standing on AC?
Sir, if you want to go for in less time, you are getting now, sir. See, if suppose there, if I go for 120 miles, it is giving within 3 hours, it is full charge. You can ensure someone who is able to afford the amount, someone is they're in hurry, they want to go fast, then definitely 120 miles 1 per hour charge. You are looking at this power rating. So people are look at how many hours my vehicle will be fully charged. They need to ensure So if it is the case, if I take DC level of 1 charging, within 3 hours it will be fully charged. If I take AC level 2, it will take 5 hours to charge fully. If I take DC level of 2 charging, DC2, fast charging. That is of within 1 hour, 500 kilometers I can ensure. So based on how much time it has to be, or based on the cost, if you don't mind, so people will go for a lesser time. No, it is not possible night time I will go and charge. Sometimes time is very precious. People who don't bother about that finance issue, even they can charge and they can go na, sir. You understood my point?
Yes, sir. Yes, sir. Thank
You are
you.
talking about rating point of view. I'm talking about time point of view.
Yes, sir. Yes, sir. Sure, sir. Got it. Got the point, sir. Yes, sir.
Thank you. Thank you, sir.
Any questions from the participants? Otherwise, we'll conclude. Any questions raised from participants? Please ask. Okay. Sir, shall we conclude the session, sir?
Thank you, sir. Thank you, sir.
Sir, please, sir. So really, I thank to Dr. Suresh Mikili Garu from NIT Goa. From my bottom of heart on behalf of EEE department. And I'm very thankful to you, sir. You spent your valuable time with us, and you covered so many things in this session, sir. And participants are very enjoyed this session a lot. And you cleared all the questions what they asked in this session and doubts. It's a very grateful to us, sir. You're with us, and thank you very much, sir, Suresh, sir. And I thank to all the participants once again. You spend your valuable time with us. And one more thing is the feedback link is available in both Zoom and YouTube channel also. So just please fill it that feedback link. Thank you very much. Thank you very much, sir.
Thank you, sir. Thank you. Thank you. Thanks for the participants. So much patience you have listened this much time. Okay. Thank you.
Thank you, sir. Thank you very much. Sir, any participants, if you're having any doubts, please place it in chat box, or otherwise I will provide you the mail ID to your respective registered email IDs. Then you can ask the questions through your mail or through your mail. Okay, later. No problem at all if you're having any doubts. Okay. So I'll post the feedback link just now. Please wait.
Hello, can you send in the chat box once again, because I'm not getting. Hello.
Yes, please wait. I'll send the feedback link to chat box. Please wait, sir.